In question number 7, we have using theorem 6.1 prove that a line drawn through the midpoint of one side of a triangle parallel to another sides bisect the third side. Suppose ABC, this is a triangle, and P is the midpoint of AB. Now from P I have drawn one line parallel and this point is Q. Now according to this question, I will prove Q is the midpoint of AC. So in first step, just you write let A B C be a triangle. P is the midpoint of AB and PQ parallel BC. Let ABC means ABC be a triangle. P is the midpoint of AB and PQ parallel BC. We will prove or to prove Q is the midpoint of AC means Q bisect AC. Q bisect AC. Since P is the midpoint of AB, then I can write AP equal to PB. If P is the midpoint of AB, then I can write AP equal to PB. Using Thales theorem, I can write now PQ and BC are parallel with each other means I can apply here Thales theorem means AP by PB equal to AQ by QC. AP by PB equal to AQ by QC. Now in place of AP, I'll use PB because the value of AP is equal to PB. So in place of AP, I can use PB. And here we have PB. So write as it is equal to AQ by QC. So same number if I'll divide or same value if I'll divide, then answer always I'll get 1. So write here 1 equal to AQ by QC. Now do cross multiply. 1 into QC is equal to QC equal to AQ. QC is equal to AQ means QC and AQ length equal with each other means I can say or I can write therefore Q bisect AC or Q is the midpoint of AC. Hence proof. Now we'll do for question number 8. In question number 8, we have using theorem 6.2 prove that the line joining the midpoint of any two sides of a triangle is parallel to the third side. So suppose this is a triangle ABC. Now DE, this D and E are the points on AB and AC respectively. Now according to this question, I will apply here theorem 6.2, and in theorem 6.2 we know if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. First I will find the ratio of this side, and if this ratio of this side equal with each other, then I will say DE parallel BC. So write first let ABC be a triangle and D comma E is the midpoint of AB and AC respectively. D and E is the midpoint of AB and AC respectively. To prove DE parallel BC, we will prove DE line is parallel with BC. Now first I will compare the ratio, and if ratio side of this triangle equal with each other, then only I can say this DE line is parallel with this BC. So AD by DB equal to 1. I can write this AD by DB equal to 1 because D is the midpoint of AB. Then AD value become equal with DV value. Means if AD is 2 centimeter, then DB also 2 centimeter, and 2 by 2 is equal to 1. So if D is the midpoint, then I can write AD by DB equal to 1. In same way, I can write now again AE by EC is also equal to 1, and AE by EC equal to 1 because E is the midpoint of AC. So give equation number 2. Now from equation 1 and 2, I can compare these two now because here also 1, here also 1, means AD by DB equal to AE by EC. AD by DB equal to AE by EC. If this triangle's two sides ratio equal with each other, then I can say this DE line is parallel with BC. This is the converse of Thales theorem. So, or therefore, DE is parallel with BC. This is converse of Thales theorem. Hence, proof. Finally, I have completed the answer for this question.